So Paul read the introduction, so you see by the title that it's about solar observations and specifically sunspot observations and reporting them to the AAVSO solar section. And Paul mentioned what the AAVSO is. It's one of several solar sections that you could report solar observations to if you want to. It's certainly a well-known one. I'm quite familiar with it, and so I thought I'd present it here. And I mentioned the idea to Paul months ago about would this be a reasonable thing that might be of interest. He said sure, so here is the presentation we put together. And so it's pretty simple. You make your observations every day and you submit them online, and that's it. But I thought I could add a few more details that might enrich it, make it a little bit more interesting in case you're a bit curious about it. And so I thought a lot of people already do some pretty sophisticated solar observations, and so you don't really need much to make sunspot observations, and a lot of you probably do already. And so I thought I'd mention these few little details here, but as I mentioned, it's really as simple as taking your daily observations and submitting them online. And so there's a few different telescopes you could use. This picture to the lower right is one called the Sunspotter. I don't know if any of you are familiar with it, but it's a pretty safe telescope because it doesn't have any way that you could get injured. It just projects an image onto the screen in the middle. So it's one example. There's a few reasons why it's useful to submit observations. And so the so-called American Relative Sunspot Number is a long-running consistent database of sunspot numbers. And so it's pretty useful for understanding solar cycles. There are some solar phenomena that are monitored by satellite and other instruments these days, but they have timescales of maybe several decades at most, depending on the satellite and instrumentation that's used to measure them and derive them. But sunspot counts have been made for hundreds of years, and so it forms a long-standing database of very useful, very valuable information. And I have a couple of pictures here. So the one on the lower left shows what a lot of people have already is a white light solar filter on the aperture of their telescope. And the picture on the right shows an unfiltered refractor used for projection. So you may be familiar with solar projection. This happens to use a Hausfield pyramid. Anyway, it's down about, I won't waste time trying to point that out. But anyway, two other methods of making solar observations. This is a bit of a cluttered chart, but it's out of a recent monthly bulletin of the AAVSO solar section. It's online. It's freely accessible. It's one little chart that shows, along with some other clutter, AAVSO observations. So solar observations are actually in use in this particular monthly chart. So solar cycle 24 is nearly finished. We're nearly at the end of this particular solar cycle, but the green bars in the middle, along with error bars, are the AAVSO's solar observations. So it's just one example of the products that's available to illustrate the use of sunspot observations that you could make and submit yourself. And another example is this chart at the lower right. So this is just another page out of a recent newsletter of the bulletin of the solar section. This happens to be for May, and so I thought I'd point this out because it's an interesting example of the daily counts of the sunspots in the month of May. And so when I put this presentation together, the May issue was the latest one. The June issue is now online. But as I mentioned, you can access these freely available. Download them, have a look at them. Pretty interesting stuff, in my opinion. But the interesting detail you might find interesting about the month of May is that there were some sunspots first half of a month. The second half of a month, mostly zero sunspots. So most days were zero sunspots. And if you start now, if you haven't started, you will find it very easy because most days have zero sunspots and it won't take you very long. It'll be a very easy learning curve if you start right now. So that's one little detail I thought would be a good illustration of what's going on right about now. Some recent research uses ongoing sunspot cycles, and so whether it's the plasma sheet correlations with the solar cycle variation or impacts of space weather on human health or other effects of solar cycles, the point is that recent ongoing research uses this solar cycle information. So it would be very valuable research to contribute the sunspot observations if you want to do that. And so how to observe it, as I mentioned, it's not very difficult to do, but of course you always have to have a disclaimer, so never look at the sun without the proper filter. So they want you to distinguish northern hemisphere and southern hemisphere spots. And so to do that, you need to establish the location and orientation of the equator. And so you can do that very easily using one example, tilting sun software. There are probably lots of other apps and so on that can do this, but we got permission from the creator of this software, Peter Meadows, and he said, sure, you can use this. So we mentioned that in the manual that's online that you can access for how to do this. Anyway, find out the orientation of the sun. The diagram here just illustrates different orientations at different times of year. So that's why you really need to plot this projection and find out which way the equator is oriented. But other than that, you simply count the number of groups and spots. That may be pretty easy right now, as I mentioned. If you see 0, it's 0. And so fairly easy to get started right about now. But that's basically it. So all you need to record is the date and time, seeing conditions, decide whether it's excellent, good, fair, or poor, number of groups, number of sunspots, and it's highly recommended to decide whether they are northern hemisphere or southern hemisphere sunspots. And that's basically all you need to collect each day. And so in my case, it's maybe a few days out of each week is cloudy, and in summertime it's pretty good, but in winter, might be lucky to get a few days each month when it's actually a sunny day and get a good, reasonable record. And here's one example of using the online sun entry software for submitting observations. And let's just pick one particular one here, and all it has is a few days, and put in the date, the seeing conditions, the time, number of groups, number of spots. It calculates the W, which is the Wolfram number. You don't need to worry too much about it. Any remarks you want to do, and when you're done, you click upload to database, and it's really that simple. And there are some columns here for northern groups and northern spots, and southern groups and southern spots. So I didn't do them in this case, but it's recommended, or it's extra science, you could say, if you do that extra information. So that's all there is to it. Make your observations, put them in your logbook, and then each month put them in this online report form, and it's really that simple. It's actually not that simple. Because as I suspect already, a lot of people in the room probably look at the sun in sunspots every day or every time they feel like it. And it's pretty easy in some cases, but in some cases it's not very easy. And this actually isn't everybody's cup of tea. So I thought I should throw in this slide to point that out, that it's not really for everybody. Although it may be easy to do, it's like variable star observing in itself. Some people find it pretty easy, fun to do, interesting little challenge, and it contributes to science. Similar with sunspot counts. It may be easy to do. You may find it fun and easy and fairly easy to record the details. Other people may get confused and frustrated and aggravated, and it can get pretty busy and pretty complicated, and saying there's a spot, is a little spot, a pore, or is it part of a group or not, and is there a light bridge across spot, cutting it into two spots, or is it one spot, and there are a whole lot of little details that you really need to become familiar with when the sun gets cluttered around solar maximum. And so the details may bog some people down, so you may decide this may not be for you. And so that's why I thought I should throw in this slide that maybe you should not do this if you don't like those details. But some people would like it, so I thought least we can do is provide a little presentation here to make you aware of this program that's making valuable use of your sunspot counts if you want to do them and submit them. So as far as resources go, there is an online observing manual. So the AAVSO solar section put together a manual for how to do this several years ago, and it's online. It's freely accessible. You can download it freely. Don't need to be a member. Don't need to pay any membership fees. You can go and look at it and decide if you want to get involved in it or not. It's a fairly simple manual that outlines the steps that I just pointed out. And it's really, rather than put it in a big long link of where it is, you just go to the AAVSO's website, look under the observing menu, observing sections. And there's a lot of sections from exoplanets to various kinds of observing stars, variable stars to solar section. There's also the ALPO solar section, and you may be familiar with ALPO, Association of Lunar and Planetary Observers. They have a very good active solar section as well. And there's one other one which I'll mention. I thought I ought to mention that the AAVSO is not the only one. It's just the one that I'm promoting because it's quite well known across the world, and its solar observers are worldwide. It's fairly well known. They have a very good program, fairly easy to start collecting and submitting observations. That's why I'm glad to promote it. And if I didn't mention, you don't have to be a member, you don't have to pay membership dues, so I'm not here to sell you anything. Anyway, onward a little bit, a couple of resources are illustrated here. So the AAVSO Observing Guide has these sections in it, a few pages about each section. Equipment, observation and recording guidelines and notes and reporting the observations, and some other resources about sunspot classification. And here they are in the appendix. If you can read this, it may be a little blurry, I'm not sure, but several different classification systems so that you can ideally, if you become an avid sunspot observer, you would become familiar with all the little details that go into deciding from day to day if a group is splitting apart or a consistent group or emerging or becoming more active or disappearing and decaying. A lot of little details you would become familiar with. So you might want to become familiar with the different classification systems. And it helps you to decide about seeing conditions in case you're not very comfortable with that. And in case you want, it's translated into 5 different languages as well, besides English, in case that's of any interest. There was one other resource I wanted to point out. I think I mentioned the Bulletin. I did, and you can find them all on the menu, on the quick links menu on the right-hand side of each page. But as I mentioned, there are some guidelines available and some more notes about observing and recording guidelines. So if you're not comfortable with some of the details, they're explained fairly well on the website. So a lot of good resources are available on the website there. I mentioned the Bulletin, so just another quick mention of the monthly Bulletin. It's free. Just look under the solar section and follow the links to the Bulletin. I mentioned AAVSO already, and so it's a pretty good group. I should also mention the British Astronomical Association. It has a very good and active solar section that also wants monthly sunspot counts from observers. And so it's got a slightly more complicated website, but just look under britastro.org and follow the links to solar section and you'll find it. And so here is a copy of their monthly solar bulletin, also available online free. You don't need to be a member I shouldn't say you don't need to be a member. I am a member, I have easy access to these things. I shouldn't say too quickly that this is available free of charge. It is in the AAVSO. AAVSO's resources I showed you are all available without membership. And they operate the same way that the RASC does here, where you can come and check it out and not pay a thing, and if you decide to become a member and support it, you can. But anyway, the BAA's solar section is quite active, and they have a lot of good resources and about a 5 or 6 page monthly bulletin newsletter. So that's the BAA. I meant to point out the AAVSO's resources. They have a lot of resources as well, and you can download these and some other guidebooks too, also for free. Guidelines for observations and for reporting the observations too. So these are accessible on the AAVSO webpage. Just 2 examples of some of the resources they have available. It's a very good, rich resource for solar observing. So didn't want to dwell on them too much or dwell on too many details. I really only wanted to point out that the programs are in place to collect and use your sunspot counts if you want to contribute them to science. And so I just added a few other details to hopefully enrich it, give it a bit more interest, but that's all I wanted to say. So have any questions, I'm glad to help if you want to email me. And they also have a good online forum to answer a lot of questions too. So that's about it, Paul, so that's what I wanted to say.
All right, thank you very much, Frank. Any questions for Frank? We have Ron here.
You talked about, Frank, very nice, Frank. You talked about sunspot numbers going back for a long number of years, like a century or more. Are the standards of 25 sunspots on the sun the same now as they were back then?
A very interesting question, and can I answer it in a quick way? Yes, the system has been recalibrated numerous times. And so the system has been recalibrated to, as recently as the 1980s, to correlate with a system that's in place for the system of worldwide observations now being collected in Belgium. SIDC, or Solar Influences Data Center. But they've correlated several different systems. So the main system of the current sunspot, relative sunspot number, which I didn't explain too carefully, but it's actually just a count of the groups and spots combined with a certain formula, was started by a solar observer, Rudolf Wolf, back in the 1880s in Switzerland. So it went through several changes, partly because of World War II cutting off access to some information. That's because in World War II, even with the crude electronics that were available, they became sharply aware that solar influences on technology were crucial. So the Americans decided to start their own system of collection. And so eventually the formulas were put in place to statistically correlate the American system with the longer running Swiss system that had been in place. And furthermore, since then, various researchers have found different proxies going back hundreds of years to guess the number of sunspots that have been in place for tree ring and mineral data and so on, that sunspots, solar cycles influence on geophysical processes. So all those systems have been correlated too by various correlation equations that are online in various publications. So they get tweaked and recalibrated from time to time. There are various research papers about them. That's why it's a longer answer to a question. The short answer is yes. Longer answers, there are various different correlation equations online, and then they can be found in various publications. So that's my short explanation.
Any more questions?
Just a short question. Not that many years ago, there was a period where there were no sunspots, like for several years. Was there ever an explanation for that?
Well, you might be referring to a period called the Dalton minimum. But if you're talking about for several years, we're in that sort of a solar minimum right now, the minimum of a solar cycle, where there are very few sunspots. In fact, if we look at the solar cycles for the past several hundred years, we'll see that we're in a very weak and weakening period of solar cycles. So the past 50 years had very strong solar cycles. In the past, say, 30 years, 1980s and 90s into 2000, were fairly strong solar cycles where even at minimum there were some sunspots. And now we're seeing much less sunspots, so we say that the solar cycle is much weaker than it was, say, 50 years ago. It's easy to answer your question saying, yes, we're going into a period of very few sunspots and maybe spotless days for several years. The general predictions and forecasts are that we'll start the new solar cycle 25 or end this current solar cycle sometime next year, year 2020. And so we could possibly see 0 sunspots for another year, but it won't really be that way. There'll probably be 1 or 2 from time to time. So we are in that period now of solar minimum. But in the past, you're right, there have been much longer periods of very weak, near zero solar activity. It coincided with very cold conditions across Europe, medieval periods and so on, where crop failures were common and a lot of people perished, and the situation on Earth was very cold. So there's a lot of geophysical influences from solar cycles. But short answer to your question is, yes, we're entering a period of very few sunspots now. So that's the short answer.
Thank you.
Thank you, Frank. Anything else? No? Very good. All right. Thank you, Frank.